everyone, welcome to the session. In this session, I'm discussing about legacy classes and interfaces of Java programming. Let's see what is legacy class and interface. Now, we have already seen in Java that Java will have a concept called collection framework, where you will have a collection of all the data structures. By that, what is the advantage? Mainly, is we can use a simple set of operations with some simple set of methods. You can do operations on those collections. For example, like I told, like stack, if you'll take, normally in other language we have to like write the code for insertion and deletion in detail, where to insert, how to insert, and all those. Whereas in collection framework, you need not you need not write all those in detail. Only thing is we have to use directly the methods to insert and directly the methods to retrieve. Here we need not know the details of insertion and all those, because it is predefined in Java collection framework. Now the thing is, before Java collection, actually before it was created, we have a collection kind of thing, and that is called as legacy class. So it is the early version of our Java collection framework. And as we have so many collections in our Java collection framework, we don't have those many collection in legacy classes, but only few. So we'll be seeing what are those. So in short, to say, legacy class is also our collection framework only, but it is early collection framework. So to that only modifications were made, and now collection framework is developed. Now let's see in detail about the definition. Early definition of Java did not include collection framework. So it only defined several interfaces and classes that provide methods for storing the objects. When collection framework were added in J2SE 1.2, the original classes were re-engineered to support the collection interface. Now these classes are also known as legacy classes. So we have to remember this. All the legacy classes and interface were redesigned by JDK5 to support generics. Now, in general, these legacy classes are supported because there is some code that still uses that code. So that's why legacy classes is still supported. Now let's see what is there in legacy class actually. So in legacy class we have actually five classes. So what are those five classes? Dictionary, hash table, properties, stack, and vector. So even in collection framework we have all this. Some property is not there, vector is not there, remaining all there. Now one more thing, it is one more. These are the classes. Now coming to interface, there is only one interface in this legacy classes. So what is that one interface means? Enumeration. So there is only one legacy interface called as enumeration. So this legacy classes, five classes and one interface. Now all these classes and interfaces are available, that is, this legacy class is available in util package. So we have to remember this, it is in util package. And all these classes and interface, this interface is synchronized. Next, we'll see about all these in detail, all the five classes and that enumeration. First, we'll discuss about enumeration. If you have gone through the video of iterator, in that iterator, I have discussed about enumerator first. So, enumerator is nothing but it's a kind of iterator where it is just used to print the elements one after the other. And there we have also learned that enumeration is only for legacy classes, that too it is only for vector and hash table. So that's because, and also it has a drawback that it can't remove any element, and it can't it will go in only one direction, that too forward direction. So it is applicable only for uh, vector and hash table. So in this legacy classes we apply that enumeration only for two. Now let's see the definition. So enumeration interface defines method to enumerate, that is obtain one object at a time through collection of objects. So if you have some collection of objects in a vector, suppose for example, in a vector I have stored so many elements. Now I want to retrieve all those elements one after the other, then you'll use enumeration. So which will enumerate, that is obtain one object at a time. So this interface is superseded, that is replaced by iterator interface. We have learned that because it has the drawback of going in only one direction. The other one is it can't remove the objects, whereas iterator interface was overcoming that. So now this iterator is replaced with replacing the enumeration. Now, but still some legacy classes like vector, hash table, and properties are still using this enumerator. Now let's see what are the methods you have in enumerator. Already we have discussed, but still we are going through. It has two methods like has more elements and next element. So both are boolean type. So what is hash has more elements mean is it is a boolean type. So it will check that whether it has still more elements to print or not. So if it has elements, still some more elements, it will return true. Otherwise it will return false. Next is object next element. So what is this mean is it will print the next element, that is it will take the next element. Now this is related to the previous one. So what is the previous one says, that is if it has any more elements or not, it is just checking that. If it is true, it means that next element is there. If next element is there, you have to get that and print. That is done with the help of next element likewise. So if it is false, then this will not work. Now, this is about enumeration. Example already we have seen in that iterator example, iterator video. So just go through that. Now, next we go to the next, we'll discuss about classes of this legacy class. We'll start with the vector first. So vector is a class which is similar to array list of our collection framework. So in array list, what we are doing, we were just storing the elements in the form of a list. Same thing we will do in vector, but the only difference is vector is synchronized, whereas array list is not synchronized. And one more thing, it contains very legacy methods that are not part of collection framework. So vector contains so many legacy methods which are not there in array list, and vector is synchronized, whereas array list is not synchronized. So and one more thing, before this JDK5, that is before collection framework, vector also implements iterable. This means vector is fully compatible with collections, and a vector can have its contents iterated by the for loop. So you using iterator, you can generate that. So there are some constructors which are used to construct this vector class. So what are those constructors? First one is vector. Simply it will create the default vector which is initialized to size of 10. So means 10 elements you can insert. Next is vector with some specific size. Means in the previous one the default size was 10. So here you need not worry about the restriction of that size. You can include your size here in the parameter as size. Next is vector size and increment. So what is size we have seen. So we are deciding the size of vector and increment. So what does increment mean is it specifies the number of elements to allocate each time when a vector is resized for addition of objects. So when you're trying to resize for the addition of additional objects, then you can specify how many elements you can insert into that. For example, initially I've decided the size as 10. Now imagine the 10 size is over. I have stored all the 10 elements. Now I want to increase the size of my vector. Now when I'm increasing the size, you should mention how many additional elements you are going to place that. So that is INCR. So next is vector collection C. So this creates a vector that contains the elements of collection C. So means if you are taking a collection like stack here, you can write that here. So it will contain the elements of stack likewise. Now let's see the methods of vector. So here we have few methods like add element. So add element means it will add the element one by one into the vector. Next is element at particular location, that is element at index. Next enumeration element, so it will return the elements one by one. Next first element, last element, and you'll also have a method called as remove all the method all the elements, so which removes all the elements, so which is not there in enumeration actually. Now let's see one example here. So we are taking one class called as test, and I told that all these are available in utility package. So I'm importing that. So I took a class called test. I wrote main method. Inside that I'm creating the object for my vector class here. So in this, I'm writing like this: vector v is equal to new vector. So you're creating the object for your vector class, and to that object you are adding some number of elements using the method called add. So adding all these elements like 10 to 60, I'm adding to the vector. So next is I'm taking enumeration for printing all those elements. So you can create the object for your enumerator like this: enumeration object of enumeration is equal to collection object. What is collection object? That is vector dot, you can write enumeration or element. So enumeration I'll write generally. So next is, using this object of enumeration, I'll print all the elements of that enumerator. So sorry, all the objects of that collection. So here I'm checking in the loop that whether it has any more elements while printing one by one. So it means that I'll print first element, then I'll check whether it still has any more elements. If it says yes, then I'll go to the next one, I'll print, and again I'll check whether any more elements. Likewise, so every time when I'm printing, I'll check whether it has still any more elements or not. So first it will check. It is saying that it. Imagine that in the while loop it has returned true. It means some elements are there. Then it will print the next element, that is using the method called next element. So here it has added all these 10 to 60. So it will print all these 10 to 60 one by one. So this is how you'll use vector and also enumerator to print the elements. So now let's see the next class, that is called as hash table class. So what is hash table mean is, it is almost same like hash map which is there in map interface. So generally we have seen that hashing is nothing but storing the elements at random places based on the key which is generated by hash function. Same here, hash table is similar to hash map, which stores that values as a pair, like key and value pair. It's like dictionary order. So if I want to search something in the hash table, I need to have a key. Key is nothing but a unique number. It's like integer number. So based on the key, I can search its data or search its element in the table. So that is key value pair. So however, both any one of these can't be null. If key is null, we can't search. If value is null, you can't allow that. So care should be taken that these two are not null. Next is, there is one more difference between hash map and hash table, that hash table is synchronized whereas hash map is not synchronized. If you'll observe, till now we have seen in legacy class vector class and hash table. So we have seen these two till now. So if you'll observe, these two are synchronized actually. So that is the speciality. So this is synchronized. So in the beginning itself we learned that all the legacy classes are synchronized actually. So that's a point. Here we have seen a note, all the legacy classes are synchronized. That's the difference. So now let's see the example for this. Before that, let's see some constructors. So four constructors are there. Again, for this is it's same like vector class. First thing is hash table. So it will create the default hash table with size 11 here. By default the size is 11. Next is hash table into size, means you can specify your size other than 11. If you want, you can specify its size. Next is hash table size comma float field ratio. So what is float field ratio means, it is specifying the uh, sorry, here it is specifying the field ratio in the hash table. So field ratio means how many are free, how many are filled. Likewise, so field ratio should be uh, between 0.0 to 1. So it means that either 0 or 1. So it should be between that. So every time checking in this and then filling the values in that hash table. Next is hash table map. If you are using map interface, map some like collection which extends that particular um, legacy class. So this creates a hash table that is initialized with the elements in M. The capacity of the hash table is set to twice the number of elements in M. The default load factor is 0.75 is used. So this is about constructor of hash table. Next, let's see the example of hash table. Here in this hash table, what we are doing is, I've constructed a hash table. Sorry, I'm taking a hash table. In that, I'm creating the object for hash table. That is, object is ht. Now for this hash table, I'll enter the elements, and while entering, we should see that not only elements are entered, we should also enter a key for those elements. Means it's like index. So just observe what I am doing here. I'm adding the elements using the method called as put. So using put, I'm adding the elements to the hash table. And while entering, I'm also entering both the pairs, that is value and key. So here I'm entering value A and key is 100. So A 100, B 200 likewise. So I'm entering the pair here. Next, I'm taking the set. So using entry set, you can retrieve one by one in order in hash table. So entry set is one of the method of this hash table. So for that, I'm creating an object set test is equal to ht dot entry set. Now I'm using the iterator, where iterator while printing it will always check whether it has next element or not. If next element is there, then get that and store it in map.entry. So actually this in detail we'll be learning while discussing about map interface. So that is stored in M, and then I'm printing the value of that, that is whatever the key you are got it from this list, that is printed as itr dot, that is iterator dot get key plus iterator dot get value. So what is happening here, we have entered as a pair, right? So key and value we have entered. Now while retrieving, what I am doing is I am retrieving all those. So actually this entry set, what it is doing is it is entering into a key and value pair of kind of thing. So while retrieving every object I am retrieving, I am storing it in map.entry, right? So this map.entry, what it will do is it will map key value with the data value. So that it will map, and while printing, what I'll do is I'll separately print key and value in leaving space in between. So your output will be something like this, key and value likewise. This is about hash table. Now let's see the differences between hash map and hash table. So hash map, as I told you, learn in map interface. Now hash table. Now first point is hash table is legacy class, right? So it is synchronized, whereas this is not synchronized. And because of thread sleep, hash table is slower than hash map, whereas hash map works faster. And key values are not allowed here. Key values can be null. That is, key and values can be null, and order of the table, that is size of the table, will remain constant, whereas here that will not be constant. There is no guarantee that size will be same all the time. That is in hash map. Now, next class we are discussing is property class. Now let's see what is property class. So property class is used basically same like a list kind of thing. Now it is used for thread safe. That is when multiple threads are executing, they can share data with the single property objects without external synchronization. So it means that you need not specifically maintain synchronization if you are using properties. That's the main advantage. And again, here in property, the values are stored as a pair, key and pair, key and value pair. So it extends hash table class. And one more advantage of property over hash table is that we can specify a default property that will be useful when no value is associated with a certain key. So that is a advantage. Whereas in hash table, if you observe, we said that neither the key nor the value should be null here. Now here in property, if at all, if it is null, it can specify a default property uh, when value is not there. So that's the main advantage. And in both the cases, property list is empty. That is, if any of these it is null, then you can say that it is null. Next is properties as two constructors. Now one is the one which is by default it will create the property, and the other one is property with property default feature. So we have seen what is a default feature here. So default property means it will be useful when no value is associated with a certain key. If you want to do that, then you have to go for the second constructor. Next is example of a property. Now here I am taking a class called test. In the main method, I am creating the object for property, that is PR. Next, I am adding the elements. If you're adding, if you'll observe, I'm adding using the method called as put. So I'm putting two values, key and value pair, into the property object. Then again, this I'm using set. There we have seen entry set. So here I'm using key set. So anything we can use. Next thing, I'm just printing. While printing, I'm using a for loop here. How I'm printing means I'm printing all the objects of a particular set. Here, what is our set? Is this creator is our set. So because all the elements whatever we have added, that is key set, is of property is assigned to that creator creator object of set. Now this creator means it will have all the all the elements now. So what I'm doing is I'm printing all the objects of that creator object. So how you are doing one by one. Now when you are printing, what you are doing is you are printing separately object plus means was created by get property. So what is the property of that? That is string of object. So this is string of object, whereas this is object. So you'll just print like this. Java was created by James Gosling. Now just here Java is our object plus was created by, and it is printing the string. So that is pr dot get property, which is nothing but string object. So objects to string is this one. So that is how it will print. So this is about property class. Now let's see the next one, that is stack class. Let's see what is stack class says. Now here it extends the vector class. Now it is same like a normal stack, which will follow last in first out principle, and it defines only one constructor, that is stack. Same like this one, uh, just simply stack. So next thing is, if you want to put an object onto the top of stack, you can call the method called push, and then to remove anything you have to call pop method. And if you are trying to pop something from the empty stack, then it will show some exception. So you're trying to remove something which is empty actually. Now here let's see one example. I'm taking a stack object for stack class st, and I'm pushing some elements here. Pushing is nothing but insertion. I'm adding all these elements into the stack here. So after adding, what I'm doing is I'm taking the object for my enumerator. Now I'm using this enumerator method. I'm checking whether it has more elements or not. If it has more elements, I'll print all the elements one by one. And initially I'm just printing all the elements one by one. So it means that it will print all the values one by one. So here it will print 11 to 55, 11, 22, 20, 33, 44, 55. It will print till here. It printed all the values. Next, I'm doing the pop operations. If you'll observe, first I pushed 11, so 11 will be at the bottom in the stack. Then I pushed 22, then 33, then 44, then 55. Means the top element of the stack is 55. Now I'm doing pop operations for the two times. Means 55 will be deleted. After 55, who is the top element? Which is the top element? 44. Even 44 will be deleted. So I popped out two elements because I called it for two times. Then it will print after popping out two elements. What is the elements, what are the elements in stack? So again I took another enumerator. Now this object is e2. So I took whether it has more elements. If there are, just print that element. So for that I'll get 11, 22 and 33 because I popped 11 and 44. Two pop elements, two pop methods I called, so two elements will be popped. So this is about stack. Now let's see the next class, that is dictionary class. So dictionary class is an abstract class. It represents again a key value pair and operates much like map. So again actually it's in detail in map interface actually. Now although it is not currently deprecated, dictionary is classified as absolute because it is fully superseded by map class. So its functions are superseded by map class. So dictionary is very rarely used now. So again in this we have few methods like enumeration elements. Next is get the elements at particular key, and boolean is empty means it will check whether it is empty or not. If empty, it will return false. If it is not empty, it will return true. Next, sorry, if it is empty, it will return true. Is empty means is it empty or not, you're checking. Next, enumeration keys. So it will return all the keys one by one. Next, put the elements means object, put adding key with value, then removing, then size of your dictionary, it will return that. Now let's see one example here for dictionary. Taken the class called dictionary. For that, I have created the object called dictionary, which starts with small letter D. Now, in this dictionary, I'm adding some values in the pair wise, like key and values. Now, for adding this, I'm using the method called put. So, using put, I'm adding key and value pair into the dictionary object. So, I've added some elements here till here. Now, next thing is I'm printing the value at key 20. See here, value at key 20. I want to know at key 20 what is the value. For that, what is the method you are using is dictionary dot get particular key. So dictionary dot get particular key. So this is a method. This one, yeah, this one. Get object key. So it returns the object that contains a value associated with the key. If the key is not in the dictionary, a null object is returned. So I just want to see what is there at 20th key location. So for that, use get method. Similarly at 40, similarly 30 and 90. So 20 is John, Tom, 30 is 30 is not there, so you'll get null, and 90 is also null. See here. 20 is there, 40 is there, 30 and 90 is not there in the dictionary. That's why I returned null. So that's a speciality of the method. So, this is about legacy classes. So we have seen that legacy class is nothing but earlier version of collection framework, and in that it has 5 classes and 1 interface. So I hope everyone understood these legacy classes in this session. Thank you all.